What's up, everybody? This is Aircreteharry, and today I have my guest Scott Howard with me from earthen.com. And we're going to be talking about Scott's building system and his methodology, if that's the right word, for his different building system. Scott uses earth as the main material for most of his structures, but he's not bound by that. Scott's willing to work with other materials, whatever is needed for the project. So Scott, how you doing today?
Good, Harry. Man, thanks for having me on the show.
Excellent. Scott and I, we've spoken before many times. Scott's all about the earth. He loves working with the earth. He's done a lot of different build projects. How long have you been building, Scott?
Since about 1999.
Since 99. And you currently are doing mostly home designs now, right?
So yeah, lately, just kind of naturally, I've moved into basically like owner-builder training and owner-builder coaching. And I also work with people on their designs, project design.
So that's great. So you say owner building, someone's looking to build a new home, they could contact you and you would guide them along. You would do a design and work with them in the building process as well.
Oh, definitely. Yeah. I mean, I'll do sometimes just do some drawings for folks, but I like it when I get to work with people, start to finish, and I really get to kind of coach them through the whole process and help them even select contractors and keep quality control through the execution of the design.
For people out there who's looking to build for the first time, even having assistance like that, where picking out the right contractor is a massive time and money saver. It's a money saver in the sense that if you get the wrong contractor and they do something wrong, it'll cost you a lot of money. So the fact that Scott can help you find a contractor that's going to work for your project, work for your budget, and work for this building system that Scott's working with is a big help. Definitely.
Yeah, and I have my own unique design process. I came to building, from a perspective as more of an artist, a sculptor. I worked with ceramics when I was a kid. I still do sometimes. I love ceramics, and then I found out about Cobb when I was in college, and light bulbs went off everywhere, and I realized, man, this is a no-brainer. We can have a great time and be healthy and contribute to, helping the earth by making the right decisions with our materials and making healthy homes for people, and also make them beautiful. So, applying an artistic understanding to the building design, you end up with sculptural buildings sometimes.
That's beautiful. And I know you're always looking to increase your own knowledge on building and using different systems. So you recently came from Spain, right? To learn a new building system.
Oh yeah, I love it. I'm always studying. I just geek out on this stuff, and I'd say if somebody asked me, what do you specialize in? It's like, well, yeah, I mean, I was the Cobb guy for years, and then I realized earthbag was a little faster, and I could end up with the house that really looked the same. So it kind of was the earthbag guy for many years, but I'm open to, the right materials in the right place. There's no one solution that just fits every situation. So it's more about the design process, the permaculture design principles. I'm always studying. Me and my lady, we went to Spain last fall and took a workshop from this guy named Jordi Dominic. He is a world famous master craftsman in the Catalan vault building style. And this is an ancient method using thin tile vaults. So they're like pretty thin, like 3/4 inch thin bricks, fired bricks, and they glue them together on end using natural Roman cement that sets very quickly, like in 1 or 2 minutes. It starts to set up and just holds it. And so they build these big vaults or domes with no formwork underneath, and it's a superior system, really. I've known about it for years. In the US, it's called the Guastavino vault method, named after the Guastavino tile company that brought that method here from that part of the world. Yeah, I mean, there's tons of applications. I'm also trained in Nubian vault construction with Adobe bricks, and I've done a lot of earth bag domes as well.
Yeah, that's nice. Catalana vault system. I've seen spiral staircases made. And if you're not familiar, you got to look it up. Catalana vault system. And you'll see it's maybe this thick between three layers. Actually, that's probably too thick. It's probably about that thick. Where about
Yeah,
three
3 to
layers of
4 inches.
tiles. Yeah.
Yeah.
And it's incredibly strong. There's no metal used. There's no reinforcement metal, traditional metals like you would see these days. It's based on the geometry and the layering system of the tiles, plaster or the Roman cement. It's built up basically it's three layers of tiles. It's incredibly strong, and I've seen these beautiful spiral staircases that you could build with this. And what I really personally love about it is the actual look of the tile. Having that tile look on the inside is just amazing. And the Nubian arch is also, it's a system that comes from Africa. They've been using this system probably for thousands of years to build these domes in Africa where they're using earth tiles, right? Earth bricks that are made, and they
Yeah.
have these simple forms that they put up, and they'll put these bricks and they'll make a dome shape and then just fill in between the arches. Is that right, Scott?
Yeah. So, I mean, the Nubian style, I think, goes back since Egyptian times or earlier. And basically, you're building a vault. So it's like an arch that's linear. You're repeating an arch down the line of a rectangular building. And you get the first arc going, it's leaning against the end wall at a pretty steep angle, and you're gluing the bricks on to this angle in an arc, and you're just repeating that arc over and over, and it works its way down the building. Yeah, and that style is great. I mean, you can accomplish a lot of things. Hassan Fatih, Architecture for the Poor, he wrote that book, and he helped a lot of people create some really empowering architecture, because it's mostly just mud. Just the Adobe material can do a lot using that method. So it goes way back. You got vaults from Egyptian times that are still standing today because they made them like 7 layers thick, 7 layers deep on the bricks. Yeah, it's a great method as well. Just back to the Catalan vault method, those have withstood earthquakes in many locations as well. I mean, super strong. Like you said, Harry, no metal reinforcement whatsoever. It's just multiple layers of bricks, and they lay them like offset from one another so that it's like woven bricks, and every layer would have a quick setting cement between the bricks on end just to hold them in place. And once you get one shell established, you would go over that with maybe like a half an inch of Portland cement, something like that, and then lay the next layer of bricks into that. So 3 bricks deep, you're at like maybe a 4 inch thick wall. And I mean, in a place like Spain, in northern Spain, it's really dry. It's a pretty dry environment. They don't really have earthquakes over there either. Some of those vaults are hundreds of years old, and the ceiling is the roof, So what that same 4 inch thick wall has the ceiling side you see from underneath, and then that same structure is the roof and sheds the water as well. Very little maintenance required. It was originally called mau plat in the Catalan language, a little bit different than Spanish. And mau plat means flat brick.
Hmm.
So it's a very common method from that area of the world. And traditionally, they would actually plaster the underside. So their traditional look is plastering the ceiling, making it all smooth and continuous. But in more recent times, people like to see the handwork, see the bricks from underneath.
You know, last time we discussed this, I spoke to you about possibly using like regular tiles so that so anyone like looking to build with this system maybe could pick out like whatever tile they think is pretty looking for your first layer, your interior, and then you can use, whatever type of brick you want, maybe compressed brick or something, that you can make on your property for the other layers. I'm not really sure, but I did think This was one thought as to how you could have different looking bricks, or rather different looking tiles on the inside that you're actually building with. Obviously, you could build a whole structure and then tile later, but the thought is actually to build with the tiles. And it's really about getting these materials here. Like, what materials can we get in the US that would be useful for this Catalan system of building?
It's a great question, and it's something that I'm working on right now because I have the source of the natural cement. Okay, there's a company called Edison Coatings, and they are distributors of this cement that's actually mined in Spain. I went to the mine, I saw the mining process. They fire the material that they dig right out of the ground at only 1,000 degrees, and it's crushed into this powder, and that is the cement. Very quick setting, full set is in 20 minutes, and it's becomes hard in like 2 minutes. But the tiles themselves, you know, there are some companies that make a similar dimension terracotta here in the US, but they're mostly in the Southwest. Found a company out of Arizona, and there was another company like in Texas. So we're trying to just figure out how to get some, to Oregon at an affordable price. And so far I haven't found it. It's not affordable. I think it's going to be more affordable just to make our own here. And so I'm reaching out to my friends in my ceramics community here locally. And we have some big, stand up like kilns, wood fired kilns. And I think that with some effort, we can actually make our own bricks here on site.
Sweet.
You guys can see some of the photos from the actual workshop. So here we are placing the bricks using a wooden form. You see this form is, really lightweight form made out of wood. It's a quaternary arch, which means that the curvature of the form follows the same curvature that a chain would make when hung. So that curvature would be upside down. When you hang the chain, you draw that same curvature on a board and then flip it right side up. And you actually have the shape of gravity, which is the ideal shape to oppose gravity. So see, this wooden form is we actually use to lay one arc of bricks at a time, and then we move the form down to do the next arc. The bricks are set in a running bond. We mix up the natural cement in very small batches at a time. Pretty much just enough mortar. It's about like this much at a time. That's just enough to set one brick. And by the time you set one brick and you tap it in, the mortar's already setting up, and you got to clean out the pan really fast so that it doesn't get too crusty on there. Clean out the pan, you reset, you put some more water and some more powder in the pan and mix it again for the next brick. They have a really amazing variety of terracotta bricks in Europe, because this is one of their main construction methods over there. And these were basically extruded. These are manufactured by machine, these particular bricks. So they're extruded, and each brick being, what are they, about 5 by 9 or something in that realm. And when you look at the end, each brick has 3 square holes that run the whole length of the brick. So they're super lightweight, a lot of air inside of them. And yeah, so that's how you proceed. And here's a couple more photos.
Yeah, that's really amazing because although this is a small scale that you guys were just practicing, you could envision this being like 24 feet wide, right? And just building just a large arched structure.
Oh yeah. I mean, and they build very low arcs as well because of the strength, the very, very high compressive strength of the bricks themselves and the cement. Overall, very strong method with the 3 layers of bricks. They build arcs that it looks almost flat. I mean, they'll build some very low arcs that are then supported. They're buttressed on the sides by very thick masonry walls, because there is some like outward force. I believe there's some outward force. When you have an arc, it's pushing outward, but the weight of that roof being only 4 inches thick isn't that much. And then the walls on the sides would be, a foot thick or something, a couple of feet thick. So it's a negligible amount of outward pressure. So you can do a lot more than just the catenary vault. They have hemispherical arcs and much lower arcs as well.
To the left of the gentleman working on there, is that going to be a staircase that are going up to the platform there?
Well, these are just demonstrations. That's not particularly a staircase, but it could be. I mean, that could be a staircase. And that's just showing kind of half of a vault, basically, a vault that terminates at a wall.
Right.
But yeah, this gentleman here, this is Jordi Dominic. He's famous. You can look him up online. He's on YouTube and Facebook, and he's actually going to be guest speaking at the upcoming bioarchitecture primer course that we're doing. And you're going to be a guest speaker as well, Harry.
I'm looking forward to it.
I'm excited about that. Yeah, it'll be really interesting because Jordi, he doesn't speak English. So I went over there and learned from him because I speak Spanish, but I wasn't sure if I wanted to try to do the live translation, for him,
Right.
Spanish about this really technical topic. But I just learned that there are some AI tools. I think we're going to try to use the AI to assist me in live interpretation of his talk.
In that picture above his head is one of the lower arches you were describing, right?
Yeah, so that's showing a lower arc. And notice there is a tension rod in this mock-up. These are all mock-ups, right? But
right.
we actually have a tension rod here because there are some outward forces that I was talking about. But yeah, then we plastered over the whole thing. This particular mock-up that we created had intentional sort of back and forth movement built in, sort of like a wave built into the vault. So it wasn't just straight. We decided to make it kind of move back and forth just for interest,
Yeah. That actually would add strength to it because the more curves you have, the stronger you could build a structure.
I think it could add some strength. Yeah.
I really love these designs using this catenary vault system.
I mean, I am so jazzed about this. I really can't wait to do more of these. And what I'm noticing is it's kind of like there's a cultural, it's not culturally understood. It's not normal here in the US. People haven't seen it that much, even though the Guastavino Tile Company built over 10,000 vaults between like 1890 and 1920, something like that. They built a lot of structures, and a lot of them are giant, bus stations, train stations, public buildings, courthouses that are still standing today. A lot of them are like East Coast or Midwest. They're still there, but the overall awareness, especially out here on the West Coast, most people, I tell them about this, they hadn't ever heard of it. So, my feeling at this time is like, when I get more free time, I'm probably going to go back to Spain again and continue training with Jordi, just because he's such a great guy and he's really generous with his knowledge. And this was another mock-up that Jordi did at the same location in an earlier class. And I was really impressed with this staircase, the spiral staircase like you were talking about. This is only 2 bricks thick. So it's like 2 inches thick, maybe less. And I could run up this thing and jump up and down on it, and it wasn't going anywhere. No cracks, like incredibly strong.
It just looks really cool.
It's marvelous. It's marvelous. Yeah. And Jordi's done a lot of these staircases in some really, really fancy homes. But yeah, the engineering, the calculations that the engineers can do to prove why this is so strong are just now catching up with the construction in 2023, so they basically didn't know how to show why this was strong enough. So they wrote this building method out of the codes in the early 1900s, after the Guastavino Vault Company was just doing amazing work in these huge vaults. Like huge spans. And they would put tons and tons of sandbags on top. They would even point load it, and they would show, look, they would prove clearly physically it was strong enough after they had built it. But that wasn't really enough, because they just stopped having this method in the building codes, because it's hard for an engineer to say, yes, I'm stamping this and I approve it, because they can't do the calculations. But now advanced technologies, advanced software really, and advanced mathematics are allowing us to potentially prove with math why these are strong. So they should enter back into the mainstream vocabulary of construction methods.
And I think videos like this, where people like you and myself are discussing this, just to bring more awareness to people that this system has existed for thousands of years, probably. It's something to consider because to me, I mean, what I see here is obviously a ramp, but I guess later you could see the stairs, the shape of the stairs against the wall, how the flat areas for you to step on will be laid. And that would be really interesting to see how that portion's done. But what you have here is your foundation for the steps to be placed. And I would love to be able to walk up to a second floor, up a staircase like this that I built myself. I mean, that would just be amazing and so beautiful looking.
Well, it's just so light and yeah, nice shape, and then you save a lot of space. I mean, if you were trying to do the same spiral staircase out of reinforced concrete, it's not going to be so. Not even reinforced concrete would be as gracile. It's not going to be the same. So you save a lot of space and a lot of material.
Yeah, that's really, really nice.
So yeah, here's Jordi giving a presentation there in Spain, and we're talking about he built a software that assists him in doing some of the calculations or the curvatures that he would use.
Yeah, it's so nice. So I'm looking forward to a future build you do using this method. Now we'll be moving from these Catalan vault system, which you've just recently took a workshop in Spain. And let's see more of the style that you currently have experience building and some of the structures you've built. And just
Yeah,
to give people an idea of something they could have built if they contact you for design and for your assistance in building. Because I know a lot of people like using earth for building their homes. Usually, one, because of the cost is low, because you're using usually local soil is the ideal conditions when you're building these earth style homes. Cost, labor, like what's an average earth bag or earth cob home run a person? Like what would it normally cost somebody if they're on a real tight budget, but they want to have something nice and safe to live in?
I mean, I tell people it really depends because people are so used to their modern, like very finished, like not dusty, very kind of fancy modern aesthetic, and that costs more money. And it also takes more skill to execute properly. So you can range anywhere between like kind of caveman-esque or sort of like mansion-esque, luxury, and it'll cost you different amounts. But if you want to do a lot of the work yourself, the great news is that, I mean, you can pretty much learn the basics of earth bag construction or cob construction in like a couple of days. And you get the basics, and then you can, once you understand the basic principles, you can pretty much guide yourself and teach yourself how to do it right. Maybe have a little guidance from a professional like me, you know, and you can build yourself a structure. You build a small structure first and then build a bigger structure. And because you're doing the work yourself, although it may take many, many, many hours, partially due to people's lack of experience, but being that they're doing all the work themselves, it can be quite affordable. I mean, you can do it for maybe half the cost of some other construction. But generally nowadays, I start people out. The conversation is $200 a square foot, and I think at $200 a square foot for like a modern finished home, that's still a very good deal in the United States in 2023. You can go higher than that easily. You can easily spend more than that. But if you want to, hire somebody else to design and build a natural building for you, it may or may not be cheaper than your standard construction, just because there's more things to figure out. There's more handwork involved. So labor is very expensive. If you don't do the work yourself, it'll probably cost you more than a standard stick-built home.
And this is why in the beginning when you mentioned you could assist people with the contractor, if someone is looking to have it built for them and don't want to actually do the labor themselves, obviously it'll cost money because labor is always more. But if you have the right contractor who's familiar already and doesn't have to learn how to do this, that'll speed the process up and make your structure a lot safer. Because someone just learning could make mistakes. I know, as an example, the earth bag dome, if you don't layer your bag system correctly and have the correct offset, you could potentially have a very dangerous situation where the top could collapse in. So, like, as an example, this is where someone like yourself, someone with the experience, can explain to people and teach. You need to have a certain offset so that you do have a safe structure, because a lot of people might just jump in, think they know everything they need to know, but end up having a very unsafe structure. So really, building a home to live in for yourself or for your family, you always want it to be safe. Safety should be your number one priority in building, so that you're safe in building, you don't have accidents, but so that when you're done, your structure is sound and safe. So what can you
Yeah.
say about that?
Yeah, I mean, all masonry, whether it's stonework or brickwork or earth bags are like giant rammed earth bricks. You know, they all have the running bond. That's that offset you're talking about, where there's properly each brick overlaps the previous layer halfway, so they're holding one another in position also by friction, and it's just safer that way. And that's true of when walls intersect, they also have to intertwine. And you know, there's a lot to it in terms of the engineering and the structural part. And you know, I don't know it all either. I hire engineers when I have big buildings, you know, or anything that's complex. We got to get permits for something a little bit different. We need an engineer just so that the county agrees, you know, just so that nobody questions it. Look, we got the engineer professional stamp of approval. That way, no one can really question it, you know.
Right.
Whether or not you think it's good or not, well, just double check, you know, find a friend who's an engineer. So that helps, and having that philosophy. If you want to do experiments, I love experimenting. I am a researcher. You know, I've done a lot of experimental buildings, and I really want to push the envelope and just do something that hasn't been done yet. I love that. Every time I do something like that, it's a small structure. Almost always, it's never like a home. It's not a structure where someone lives in there. Might be a small outbuilding or something like that. I've done, you know, full size, you know, 350, 400 square foot building just for the sake of research, and no one lives in it. So if you really want to experiment, do that, you know, just learn by doing. And then over time, you know, when I did my big research project in Southern Colorado out there, the regenerative home, you can find that on YouTube. It's a 400 square foot autonomous natural home. And I used some pretty innovative methods on it, but I wanted to prove that it was strong enough. And it's been standing now for over 10 years. And we're still collecting data from it. No one lives in it still, because it's still, in my opinion, it's still proving itself. So that kind of thing, it's like, if you want to do some experiments, you got to have patience, planning. You know, all of our ancestors did a lot of planning. Everybody spent a long time planning the next building. They spent a whole generation planning the next house, you know. And so nowadays people want everything fast, 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 and it can take its toll. So mistakes can be very expensive. So,
And those are some great points you made, especially building. Like, I tell people this all the time when they're building something for the first time, is build something small that you can test, you could get some experience with. So like, if you were going to build an earth bag structure, build something small that you can then use as storage later, you know, or as a chicken coop or something, but something small just to get some experience, because you might watch a video, you might, you know, even go to a workshop and actually learn hands-on. But once you're back on your property, maybe you forgot some steps. So doing something small to refresh your memory And just to do hands-on is a very good piece of advice for anybody looking to build something new.
Definitely, definitely. So that being said, I will just really briefly walk you guys through some of my past work here. This is by no means comprehensive. I mean, all the projects I've done, not even all the photos are on my website or anything like that. I haven't updated it. But this is a little sample of some of my past work. So here I am. I'm 20 years old or 19 years old here. This is me with the red visor. This is down by Corvallis in Philomath, Oregon. And this was the first Cobb house that I worked on. It was 1,200 square foot. It was a meeting house, like a guest house, place to hold meetings, community gathering place. Very cool project. My first teacher was Yanto Evans from the Cobb Cottage Company. Very, very wonderful man. Made some great contributions, pretty much single-handedly, like brought Cobb construction from Wales. He's a Welshman, little tiny Welsh guy. He looks like a little gnome, you know. He brought it over here from there and had been teaching it here in Oregon since I think the 80s or somewhere around there. So Cobb was definitely my first love, and I still really appreciate what it has to offer, which is, okay, there's so many advantages, guys. You know, infinite improvisation, infinite editing ability. You can change it, infinitely alterable. It dries out and it sets up really hard. It's like a clay cement, okay? The clay is the binder. Clay will be very hard and solid when it's dry, but when you wet it again, it gets soft again. And that can be repeated as much as you want for thousands of years. So it's like you can chip away at a Cobb wall and add a niche anytime in the future. Or you can cut in a little hole and add a peg or something and make a protrusion, something coming out of the wall, or you can change it. It's infinitely changeable. So there's a lot of advantages to that as a beginner. If you build a wall that's a little bit wonky, you can fix it. If you want to change it after you've built it, you can fix it. And so to me, I think that's a great entry point for anybody. It's like, just start with small Cobb building. And
So when you say Cobb, for people that don't know, what is
so
the
Cobb is
makeup of
another,
Cobb?
yeah, it's just another name for Adobe. It means sand and clay and straw mixed together. It's a composite material, right? So you have the sand is the building blocks, the clay is the binder, and the straw is like the rebar. It's like gives it tensile strength in the mixture. And you know, Adobe is the same stuff. So they can make bricks out of it and dry them, and those are called Adobe bricks or Adobes. Or you can mix it and use it wet, and they call it puddled Adobe, like what they use in Taos Pueblos, puddled Adobe. It's just applied wet in courses. Or Cobb. Cobb is a name meaning loaf. It's a Welsh word, just means loaf. So you take blobs of this pasty, you know, earth mix, and you just apply it in place, and you thumb it in. You push it in with your thumbs or a stick, and then build it up. And it's slow and methodical, but it can be fast too. I mean, we were doing 5-gallon buckets of Cobb, dumping them. You know, we mixed up 60 yards of Cobb with a bobcat in like 2 days. So I mean, it could be faster than people think, but it's still pretty labor intensive and time consuming. Here's that same meeting house I was talking about. Our friend Kiko Denzer, he helped us plaster the inside of this. I learned a lot of stuff with him as well.
I love it that it's very organic, and that's what I've noticed about most Adobe and Cobb structures is they usually have a very organic look to them. Like you mentioned, it's basically like clay, and so you can sculpt it like these windows you have here. And that's one of the beauties of it is the flexibility you have of designing and sculpting and creating on the go.
Oh yeah, so fun too. So much creativity. Everything, every building is one of a kind. They're all one of a kind, and it's a complete reflection sculpturally of the imagination of the builders. These windows I designed myself when I was there. You know, I'm like 20-year-old kid, and I designed these. The one on the left I called the Shazam window. I did a whole bunch of ovens. This one was an oven I did in Yucatan Peninsula. This is a drawing I did when I was 20. And here's the actual building. in construction. This is a
Okay.
two-story Cobb home I did, same location as the previous Cobb building. Benches in Portland. Here's some Cobb columns I did on a front porch. Still
Is there
standing.
anything inside of these columns for structure, or is this
Yes,
purely Cobb?
it's a pressure treated 4x4 post that was holding up the porch. And we put a bunch of, old nails and screws, give it a lot of tooth, and then cobbed over that. And then I have my own proprietary mix of oils that I painted over my plaster finish on these columns. And I've been back to these columns several times since. I mean, these columns are 20 years old at this point, not a scratch, no damage from, they get some rain at the base and they're doing just fine. So people think it'll just wash away in the rain. Like, no, it doesn't wash away that quick.
Now,
If
are
you
these
oil,
structures permittable anywhere in the US? You have troubles? Are they more or less difficult to get permitted?
it's a very complex topic because every county is different. But in the last couple of years, an organization called Cobb Code actually wrote some building codes for Cobb construction for the US of the federal level that most of the states will recognize, or it gives it some precedent and some like jumping off point for the conversation. So in places where the building departments in different counties are not familiar with Cobb or Adobe, you could still convince them that it will work because there's a code for it. And if you follow that code and provide the proper reinforcement, which would be basically a lot of rebar within the wall system, you can get a permit for that. And if you get an engineer to stamp your plans, then undoubtedly, I don't doubt you can get a permit for a Cobb building in almost any county in the US.
Now, from a lot of the builds that I've seen, I've noticed number one, like for example, Cobb structure is usually timber framing. So you have already what's currently used for building regular homes these days is a timber framing, but usually the timber framing's like the post, like a 4x4. Is usually like a heavy wood. I don't see why it would be an issue building any Cobb structure, especially when you have solid timber framing for the main structure. And then you're basically just making your walls of Cobb. So for people
Exactly.
out there who've not seen these Cobb structures built before, is a lot of timber framing. And if you know a regular modern home is timber framing with sheetrock on it, and the difference here is you're doing timber framing and you're putting Cobb and even rebar in it. So I see these structures as being much better, much stronger. Obviously, they're better in the sense that they're fireproof because of the way they're made.
Oh yeah.
Most of the wood is usually covered in Cobb. So there's barely any wood exposed for the actual structure itself. I would prefer a Cobb home over any modern sheetrock stick frame home personally.
Oh, definitely. I mean, they're definitely stronger. I mean, just for clarification, there are plenty of Adobe and Cobb buildings in the world that, they're not using the timbers as the posts. The walls are just pure earth and they go up and they may support a wooden roof on top of the earthen walls. You don't necessarily need timbers in there, but another route, if you had to get permits in the US especially, or a restrictive, building code type country, you can get a engineered timber frame structure. So the timber frame will be strong enough for the seismic event all by itself. And so whatever you fill in between the timbers will also, work with that system. You may use something lighter weight like a straw clay or wood chip clay in between the timber frame, but Cobb could also work and could be permitted in that way. You got a number of options, but yeah, just structurally, people wonder about the Adobe, and I would say it's nearly as strong as cement in terms of like compressive strength. And the truth is, there's almost no masonry building that you've ever seen that even gets close to approaching the maximum compressive strength pounds per square inch that the material can withstand. So even if an Adobe, like a weaker Adobe, is maybe half the compressive strength of a strong cement, it's the walls are not nearly as much pressure, even at the base, as it can withstand. It's maybe like 1/5 or 1/10 of the compressive strength is the amount of force actually pushing down right there. So it's not really the compressive strength of the material that we need to worry about. It's more like the shape, a seismic event. If you have very heavy walls and they're not like held together properly, they'll shake and they can crack or they can fall. There's potential for that. But during certain shake tests, they have a shake table that simulates an earthquake, right? And they built a miniature, like a 1/3 scale, like Cobb house on top of the shake table. And they shook it as much as they could up to like a 9.5 earthquake simulation. And it cracked, but it didn't fall down because all those straws in there kind of hold it together. And so you see that also in a lot of places. There's been seismic events. And if it's a monolithic cob, aka puddled adobe, it tends to perform pretty well. Whereas anything made with bricks, and there's no rebar in a brick wall, that can come apart. Those can fall down on people in earthquakes. This was a sound meditation dome that I built in Thailand with a workshop, like early 2000s, and this was like a 23-foot tall earthbag dome. It's one of the largest earthbag domes in the world at that time. One of my favorite pieces. It's a little Cobb meditation hut.
Let me ask, are there a lot of straight walls when it comes to like Adobe or Cobb structures? Because I know the curved walls add to the strength of the structure, but how about flat walls? Are there a lot of flat walls done with the Adobe and the Cobb?
Oh yeah, I mean it's totally doable. So just to clarify, if you look in the building codes in like Texas, Arizona, New Mexico, that area is Southwest, there's codes for using Adobe brick that are, some of it's reinforced. A lot of times they have, cement mortar. They'll have a stabilized Adobe with a little bit of Portland cement mixed into it. Traditional looking kind of Western homes or have straight boxy homes, and a straight wall has to be buttressed. So there'll be a perpendicular wall coming off of a straight wall that gives it a little more footing, so it
Right.
doesn't tip over. Being that curved walls are self-buttressing, a curved wall won't tip over because it's already kind of got more width of its stance. It's superior in some ways, and being that Cobb really just lends itself to making curves anyway, we can kind of just go with the flow, right? Just go with the flow. It wants to make a curve, so make it curved. But yeah, you could build there. There's plenty of homes, like especially Wales, Southwest in the U.S., in New Zealand and Australia. They're very classical looking, very kind of European looking straight wall homes. You almost can't tell it's made of Adobe or Cobb, but it is just boxy, normal looking home.
So I noticed in this photo you have the tree there. Oh, and you got a living roof. So the tree is one of the benefits of using the Cobb is you can design and sculpt any design you want into the side of your structure. And that's one of the beauties of it that I appreciate, being able to do different designs like this. And that to me almost looks like a family tree, like where those bottles are. You can almost have a picture of everyone in the family.
Oh yeah, yes, it's sculptured to your heart's content. 100%. You can make anything you can imagine, and it's a lot of fun. And you can do this in an earthen plaster over a lot of different substrates too. I mean, you could put earthen plaster over earth bag or straw clay, or even a plywood wall. If it's strong enough, you can put a relief sculpture onto it using the same materials.
I can see how this structure here with that living roof would be very cool on the inside on a hot day. Is that so?
Oh yeah, the structure is really quite comfortable year round. I mean, it doesn't get extremely hot or extremely cold here in Portland, Oregon. Yeah, having the 3 inches of soil on the roof and then 18-inch thick walls made of cob, it's the temperature doesn't change that much in there. It's always like a cool, like maybe 55, 60 degrees. It's pretty nice in there.
How long would you say this structure here took to build? And how many people were helping?
I had maybe around 200 volunteers come through at different times for pretty short periods of time. Some of them were like 3 or 4 year olds,
Mhm.
but they helped too. And it took me, good question. It took me probably a couple of months over 2 different summers. So like 2 months the first summer and maybe 2 months the next summer.
Nice. Yeah, very nice looking. What size is that?
It's about 120 square feet. Here's the oiled earthen floor inside that same building. The standard like linseed oil
Okay.
layers that I learned from Yanto and Cobb Cottage Company.
So I guess one of the big benefits of this floor is walking on it barefoot. You're grounded. You are always grounded in this house.
Exactly.
And if you don't know, look up grounding or earthing. There's a lot of health benefits to being grounded. So to have a home you're living in that you could be barefoot all day in and be grounded all the time is really good for your health. You'll be surprised at how many different ailments you can cure by just grounding yourself. And it's really a key thing. It's one of the reasons I'm planning on using an earthen floor in some of my structures just for that purpose of being grounded. So yeah, that's great.
Yeah, 100%. Yeah, earthing is where it's at. I mean, it's so much more important than I ever realized. And now that I've been studying more electrical engineering of it, and hearing about the effects. You got to watch those documentaries out there about earthing. There's a few of them, and really good stuff. Really important.
I'll leave a link in the description box to a documentary. It's you can see it for free on YouTube. It's a great documentary if you haven't seen it.
Yeah, that's a good one. Yeah. So in the earthen material, it's kind of soft. Like it has its advantages and disadvantages. Of course, you can't wear like stilettos on it or have like hard metal legs of chairs or tables. That is a no-go. You can have a little like dish holding a sharp leg to keep it from poking in. But it's nice that it's a little bit softer. Like if you're standing up all day, if you ever stood up all day on concrete floor, I mean that'll jack you up. It's so hard. But this is a lot softer. It's a lot more inviting to the touch and for standing on, easy on the joints. You can even put a thin earthen floor, say over a concrete slab, and it will soften it right up so that it feels a lot more human.
That's an interesting idea.
Here's that same building in process. Here I am in the Earthbag Dome. That's in Thailand. Yeah, it was a sound meditation chamber. No windows and just two doors, so that there was very little openings. And you go in there and it was a quaternary vault, quaternary dome shape. So the sound would just resonate in there and bounce off the walls. It was very, very echoey. It was good for like toning or playing some toning type instruments, droning instruments.
Nice.
Oh, this was a big accomplishment. I had done this outdoor Cobb bench cafe, a very prominent intersection here in Portland. That was pretty cool. Here's that sound meditation dome completed.
Nice.
Yeah, and then here's a series of benches I did at different schools. I did all this stonework and a lot of volunteers, a lot of kids came through and learned how to mix cob with me here at these sites. And
Would you say one of these benches is probably a great way to start with the cobbing experience if you've never done it before?
100%, you got to get a feel for creating this composite material because you can put more sand or more clay or more straw or less straw, and each type of cob will be for a different purpose and have different strengths and weaknesses. So you really got to get to know your mixtures, and really that has served me all through my construction. Is just my design and construction career is like a lot of it's based on composites, understanding composites, the performance of materials, materials-based design, where you become intimately familiar with how the materials perform. You got to play with it, break it, light it on fire. You know?
Yeah.
Whatever the material is, you got to understand what it does. You know, up close and personal.
And the wood in this project, this was all locally sourced wood?
Oh yeah, yeah. Pretty easy to find some nice Doug firs. Here's a earth bag home I did for a friend of mine, and we actually sourced all of the wood. The main beams for the roof were cedar trees that were already standing dead. They were naturally ready to come down within 30 yards of the building. So it was pretty easy. I cut them down and I debarked them and drug them over and put them in the building.
Yeah, it's really pretty looking. Again, I love the organic designs with the curve and the swooping roof lines you have there. It's really nice.
Yeah, this one turned out great. It's kind of like a mushroom house or something, mushroom shape. Oh, here's some people at a workshop I was teaching. We're installing an earthen floor, so you kind of see the process there. Guiding the depth, where we put down a layer of pumice, and then we put down some 2x4s to make sure we continue the same depth of the cob.
Okay, yeah, it looks great. And I can see the start of what looks like staircase on the wall there.
Yeah, there's a like a cantilevered staircase coming out of the wall.
Nice.
So this was actually what they would call a load-bearing straw bale. So most straw bales have wood components in the walls. That the wood is what's holding up the wall, and that's a great way to do it. But on the more experimental side, I wanted to do for this shed. We just laid up the straw bales and then built the living roof on top of the straw bales, and the straw bales are actually holding up the roof. So that was a fun project.
Yeah, that came out nice.
Here's a earthbag dome I built in Mali, in the Dogon country. It's actually eastern Mali in West Africa. And this was a donation I did for the primary school there in this small town village called Tirelu. And yeah, we had a big workshop. Of international crew of students came through, and we built this 16-foot dome. It ended up being more of kind of like a play structure for the kids.
Yeah.
They would hang out inside there, and they would climb up on top of it, and it was good fun, and it was very interesting, like cross culturally, because the Dogon people are master masons. I mean, they know adobe and earth plasters and earth construction super well from like thousands of years back in their tradition. So they are master masons and they understand all about that stuff. And they taught us quite a bit. And but they were not familiar with the dome shape. So for them, culturally, they were not super into the dome shape. They were like, "That's interesting. You guys are some pretty crazy foreigners and building this dome." Like, yeah, they're like, "We don't really trust it, but good job."
Yeah.
It's really funny.
So it looks like all the materials were locally sourced.
Oh yeah, yeah. This is all earth. So this is an earth bag dome. So there's those sacks and there's the barbed wire as the main structure. But other than the bags and the barbed wire, all the materials come from the site itself.
So
And
that's
that's
what
kind
you
of
buy. You buy a bag and barbed wire and
yeah.
you're good to go.
And I think we used like maybe 4 bags of cement powder in the whole building. And that was just so we could anchor the metal door so we could lock the building. We
Yeah.
needed some cement for that and maybe a little bit of cement, I forget, here and there, like in the rocks to hold the foundation together a few places. Not very much cement at all.
Yeah, I mean that's great for not needing much materials at all, but bags and barbed wire.
Yeah. So what you see here is a hyper adobe earth bag rammed earth walls with the buttressing on the sides there. Just sand and clay, no straw in the bags. on top of a gravel bag and a level trench foundation. And then the Nubian vault method using the Adobe bricks uh, for the roof. And this is as far as we got using the unstabilized Adobe. So most of the building, probably like 80–90% of this building is Adobe, is just earth. But then to complete it, we actually did a ferrocement. So this part that's kind of hanging out in space, I didn't feel comfortable, putting heavy masonry in that part. That wouldn't have worked physically. So we made it light, it has air on the inside. We anchored it back to the rest of the structure and ended up creating kind of a ferrocement brim, like a baseball hat,
Right. Yeah, you got a little visor there.
a little visor. So that covered the rest of it. And you can watch a very detailed video I put out on YouTube. It shows all the steps of this construction. There's no commentary. It's just for people to see. I didn't hold anything back. I showed all the steps in video, exactly how we built it.
Yeah, that's great. We'll have a link to that video in the description box below as well. It's really cool to see that you've taken all these different methods that you've learned, and now you're just progressing yourself, as you say, what do your clients need? What do the people want to build? And now you have all this experience with all these different methods that you can do a mashup to like really create something unique and beautiful for people.
Yeah, and it's like a vocabulary, right? So we got pattern language, our design language of different patterns of existence, what people need, the way the energies flow around the space, like what kind of architecture does this, and different architectural shapes for certain modes of existence, so we work with that, and then we also work with what materials do people have available, and then we can take it in a lot of different directions. So that's what I like, is to help people discover a more effortless mastery. What should the vernacular building style be for each location? It depends on what's there and what you have available, and the forces that you have to work around.
So that's awesome.
And also review architects' designs to try to preemptively solve any problems with the building envelope, which keeps the moisture out, and you gotta have the right amount of vapor that can escape. And there's a lot of building science involved with working with water and air and vapor, which are like three different things. Like, you think water and vapor would be the same thing, but they act pretty differently. When water becomes airborne, it's vapor, and it can condense inside of like roof systems and cause rot and all kind of problems. The design details and try to prevent those kind of issues. And so I'm looking at different types of building materials, looking at the conventional building world, and understanding what's going on from that side, because I was sort of like a self-taught bioarchitect, like for a long time, for 20 years, and now I understand what's going on with the conventional world as well.
Yeah.
So we can draw on all those things now.
Yeah, well, that's part of why I wanted to have you on the show today, because my plan is to interview different people who have different building methods. And I want people to out there to see there's more than just my building system or yours or earth ships. There's a lot of different building systems out there. And I'll be touching on all those different building systems that exist that I find to be beneficial. As an example, with these Adobe bag and Cobb structures, the fact that you're using natural materials, the fact that we're learning more about the energies, or as a lot of people might know it as feng shui in a house, how the energy flows. And these things really do make a difference to how we live, how happy we're going to be, if we're going to feel down or energetic. And so my structures are cement Your structures are earthen, as your website shows, earthen hand. I know you have a workshop coming up, and it looks like August 26th to the 27th, September 9th, 10th, the 23rd, the 24th. So you have a bunch of days here. What's going on with these upcoming workshops that you're going to have?
Yeah, thanks for asking. Okay, well, yeah, the workshop is it's called the Bioarchitecture Primer, and essentially this came about because I realized that we absolutely need to integrate the latest science into our design language to properly design and create holistic natural homes. And that was brought to my attention mostly by Dan Winter, uh, research scientist and electrical engineer, that the forms and the materials, different buildings, create a different capacitance electrical field in that space. So there's sort of like a frequency signature, let's say, that you can measure and is a real thing. It's not like a woo thing, you know, like you can measure it and it will, from our measurements, we can prove repeatedly why certain forms and certain materials will promote things like plant or animal growth more than other forms and materials. And so what we found is that the high dielectric materials that are natural materials, like stone or wood or adobe, they perform better. And also, interestingly enough, sacred geometry forms that incorporate, you know, phi, the golden ratio, tend to perform better than some other forms. So that's a gross generalization, but we can now measure, and that's the point. Is like we could build any building now, and after it's built, only after it's built, we can measure it. And so as Dan always says, you know, this allows us to decide which architect should get a paycheck and which one should not. So that's kind of where I came from in this particular workshop, was to integrate that and provide a very comprehensive and holistic design framework for beginner natural builder and beginner designer. Because a lot of people have dreams, and I think that people will be able, if they're just a little bit more informed, then anybody can contribute to the design of their own home, maybe work with a designer hand in hand. And so that's the idea. We're going to do 6 days online and 3 days in person to do some hands-on training as well. Basically, I'm going to guide the whole class of students through, you know, design principles and design language, doing some sketches, doing some drawings and some models. And we're going to have a series of guest speakers that are going to knock your socks off. Like I said, we got Aircreteharry, we got Dan Winter, we got Larry Santoyo, famous permaculture designer, who was my original permaculture teacher back in 2005. And we got a couple other very prominent bioarchitects, Arturo Ponce de Leon and Michael Rice. And then we have a good friend of mine, Anthony Dente, who's a structural engineer that specializes in natural buildings and alternative buildings. And a whole bunch of other people. Really, it's going to be very interesting. Ahmed Wafiq, for example, he's Ahmed Wafiq Designs. He's an architect and professor in New York State who works with biogeometry. So talking about the subtle energies as well, you know, reaching forward to what should architecture do for us? How can it provide us with a deeper sense of well-being and wholeness and health? And I think the energetics are where it's at. So we can measure certain aspects now, and we can confirm if it's working or not. And then in even newer aspects of the science, we can't quite define and measure why things are working, but we've discovered certain things that work. And so I would characterize that biogeometry is kind of fits in that category. There's certain things that we find that work, can promote a healthy environment in buildings. Whether or not we know why it's working is a different question. But yeah, we'll get into all the the design process with the students, and we're just gonna have a good time, and then we'll get into some hands-on and build a scale model of the design that we create, the collaborative process in the classroom.
Yeah, well, that sounds really exciting. Sounds like one-stop shopping thing where you can get all the information you need at one spot. And yeah, I'm looking forward to it. And I think that's going to be a lot of valuable information for a lot of people who are interested in designing their own home and building and just to get it right. Because, these past few years, a lot of people have been leaving the big cities. They've been coming out to the more rural areas to live a more natural, peaceful life. That's what I did. I left New York City, come out here. I'm surrounded by nature. I get birds and deer and elk constantly singing, chipmunks, and, all the beautiful nature things that I just really enjoy being around after living in the city, the largest city in Brooklyn, New York. It's a big change, and I know there's a lot of people that are making that change as well. And there's a lot of things happening in the world, and it's good to think about these things now. If you want to leave the cities and you want to get yourself even a little half-acre property anywhere and build something really inexpensive but solid. I love these structures. I love what I'm building because they're solid. I love these earth structures because they're just solid and they're safe. And yeah, they're great. So, Scott, thank you so much for coming and allowing me to interview and just showing us some of the things you've been involved with. It's been awesome.
Oh yeah, thank you, Harry. This has been a good time, and I really appreciate this conversation. And yeah, there are many more to come. We've been generating some great brainstorms together, and just looking forward to more of that. And yeah, thanks for all the knowledge you've been sharing, because I've been just super inspired about the airforms and the potential of aircrete and thin shell cement. And yeah, we're right on that. What I feel is a pretty cutting edge stuff. And I was on the phone yesterday with the owner of the Aircrete company that makes the magnesium cement foam insulation. Aircrete with a K.
Yeah.
That guy Keen. He's a really cool old guy out of New York State, and they actually need some people to carry the torch for that out here in the Western states. They don't even have a representative. They're like, "Can you find somebody?" So anyway, there's just a lot of opportunity, and I think that going back to like the more bang for your buck and creating durable structures that are going to serve people in their homesteads. Um, you know, we're looking at some thin shell cement solutions and using some aircrete insulation solutions. I think that's going to be a great addition to the design vocabulary.
Hey, that's awesome. All right, great. So, Scott, I look forward to our next talk. We're always, like you mentioned, brainstorming some great ideas. And I think later this year we might be able to implement some of those ideas and share them with the world. And like you mentioned, one thing I'll be doing myself is my own energy testing because I have my own BioWell device now. So I'll be able to test my structures and compare to other structures and just show people how there are these energies and they are affected by the shape of your structures as well as the materials you use. So I think that's really important. I'm looking forward to finishing my structures and testing them and just showing the world what this geometry and these biostructures really can do for the human body and for your mind, your soul, and every other good thing.
Oh yeah, that's what's up.
Mhm.
Everybody's into it, the biohacking and just being healthy. Yeah, thanks for your contribution, and looking forward to what we come up with here.
Absolutely. All right, Scott. Peace
So,
out. I
thank
love
you.
you and I love you all, and I'll catch you later.
Yeah. All right. Talk to you soon.